conditions of triangles. So I'm going to be working on the activity slide 2, and I'm going to be doing numbers 1 and 2, with you. So what I'm going to do is I'm going to read through them and I'm going to work through the problems with you. It says Margaret created 3 lines made of Play-Doh that measures 4 inches, 5 inches, and 5 inches. Margaret thinks that she can arrange the 3 pieces to form a triangle, but her brother Derek thinks it is not possible. So, what I'm doing right now is I'm taking some sticky notes and I'm going to pretend that 2 are 5 inches and 1 is 4 inches in length. So, let me just make my 4-inch one. What we're trying to do is you're trying to see if these 3 sides can make a triangle. Now, because I'm a visual person, that's why I like to make things. That's why I like to actually get all hands-on with the assignments and stuff. So, if you if you feel the need to do this at home, you can totally make Play-Doh at home that are 4 inches, 5 inches, and 5 inches. You don't have to just sit there in front of a computer screen and try and guess. You can do what you need to understand the material. So, big face, big brain. So, here are my 3 sticky notes. I'm going to say this length is 5 inches, this length is 5 inches, and this length is 4 inches. So, I have my 5, 5, and 4. So now I'm going to try and rearrange them to see if I can make a triangle. So, maybe you can see with me. Swoosh. No, okay. I'm just going to do this. Okay, so if I put this one, I don't know, here. And then I put this one here. And then I put this one. Oh, guys, I am so close. You see how close that is to making a triangle? So, now you can't stop here. You can't say, oh, no, I didn't do it. If it was close, then it can. So now I'm going to try and rearrange them so all the corners match up. So, if I can make this one just go a little bit further out. Almost there. Almost there. In fact, aha! Let's bring it down a little more. I did it! So I have made an isosceles triangle. Whoop, this way. Because I have 5, 5, and 4. So now if I were to outline this triangle, I have 5, 5, and 4. Ta-da! So, in order to make a triangle, the 2 small sides have to be greater than the bigger side. So, my small sides in this triangle, since I had 2 5s, one of those just gets to be one of the small sides. So, I get to pick. So, let's say I have this 5, and my other small side is 4. So, I have a 4 and I have a 5. So, 5 plus 4 has to be bigger than my biggest side, which is 5. And what is 5 plus 4? Well, 5 plus 4 is 9. Is 9 greater than 5? Yeah, so it's going to make a triangle. If I had like 1, 2, and 3, my 2 small sides are 1 and 2. My big side is 3. 1 plus 2 needs to be bigger than 3. 1 plus 2 is 3. It's not bigger than 3, so this isn't going to make a triangle. This is actually just going to make a straight line. So in order to make a triangle, the 2 small sides have to be bigger than the third side, or the biggest side. So in Margaret's case, yes, I can make a triangle. Now we're going to take a look at Tilly. So it says Tilly and Andrew are instructed to each make a triangle with angle measures of 30 degrees, 60 degrees, and 90 degrees. Tilly thinks that their triangles will have to be congruent, which means exactly the same size. Andrew thinks it's possible for them to look similar rather than congruent. So similar just means that they're close. Congruent means exactly the same. So a 90-degree angle is an angle that has, well, it's a right angle, right? So here is a 90-degree angle. Then I have a 30-degree angle and a 60-degree angle. So if this is 90, right, that means my next angle is 30. So this is 45. So let's go about right here. So here's my 90. Here's my 30. And then I have to make a 60-degree angle. So if this is a 90-degree angle, here's 45. And let's say about right here is 60. So now, we didn't give you any line measurements. We just gave you the angles. You can rearrange these angles however you want. So you can have your 90-degree angle down here. You could have the 30-degree angle up here. And you could have the 60-degree angle right down here. Okay? So if everyone had the same size triangle, honestly, that would be very, what's what I'm looking for? There would be a high probability that this would not happen. Reason why? Because if you spaced out your triangle like this, that's perfect. But what if someone else made their triangle like this? So that's sort of similar. There we go. It's the same measurements. This is 30, this is 30, this is 60, this is 60, and then we have a 90. It's the same measurements for the angles, but they're different sizes. Therefore, if I'm just given, angles and none of the lines, they're not always going to be congruent. They're going to be similar. Now, if you give me just the side lengths, which is what we did for Margaret, I just had the side lengths. I just had 4, I just had 5, and I just had 5. I didn't get any of the angles. But just given sides, I'm always going to make this specific triangle, this unique triangle. It's a 5, 5, 4. This triangle is going to make an infinite amount of different sized triangles because you can make, because decimals or numbers can be decimals. So the side length of the triangle can be like 2.3, 2.4, 2.5, 2.6, 2.7. And when you are just given, again, the angles for the triangle, they're not always going to be congruent because you're not given enough specifics to make it a unique triangle. So there you go. There's slide 2. Hopefully that helps you with slide 3.